Okay, I am Rehan Asmat and I am the TA of this course. So today's session is about the tutorial of LTspice simulation for your project. And okay, if you didn't download the software, then please download it from the link I send you in the chat box and also in the announcement. So first of all, we download and install the LTspice simulation software. If anyone have problem installing or downloading that software, you can just type me in the chat, or you can unmute yourself and then speak up. And then I will introduce you with the software and its feature, and then we do a example that is not low pass, high pass RC filter, and then we simulate it. After this simulation, I would like you to practice this the low pass RC circuit designed by yourself, simulate it, and if you find any problem, you can we can discuss during this session. So this is the link. You can download software from this link. It has both Windows version and Mac versions. So if you didn't download it, then just download this. It will take not much time if you have good internet. Okay. Okay, this is let me check. Okay, anybody have problem in downloading or installing software, or everyone is good with that? Anybody? No problem, I will post it. Here it is. First one is the course page where you find the project and the startup guide for this software. And the second one is the page for the download of the software. So you can click on that, and then you go in this website. Let me share my screen. Yeah, this one. Okay. This is the website where you can download the software. These are two versions. For Windows, you can download from here, and for Mac, you can download from here. Just click on that, and then it will be downloaded automatically on your PC. It will take some time. Okay, after downloading, install it on your systems. Just I think 1 minute. It will take around 1 minute in my system. I am waiting for the download will complete, and then maybe I will show you the installation procedure. Yeah, it is downloaded now. When you it will download the exe file, you click on the exe file, then the installation will start. Okay, Okay, can you see the this license agreement software? I just share my screen. Everybody can see the software license agreement. You can say yes or no in the participant list, or just say yes in the chat. Can you see the license agreement? Okay, then there is yes, this installation directory. You can select wherever you like, but most it is just installation. Installation. Okay, it's just installed. Now after installing, launch the software. Okay, it automatically launched the software. Yeah. Now you can see the software as well. Yeah. Okay, this is the software LTspice. If everyone downloaded and installed it, just there is a desktop icon. You can click on that LTspice and then you can see the software. Okay. Okay, in this software, you have this toolbar. Just in first toolbar file, you can create new schematic. You can also design new symbols, but it is out of the course. Right now we will focus on the schematic and the simulations only. And then this is open. If you already designed some circuit, you can open from it. It's just normal with every software. So there is few icon. I will now go to the slides. Yeah. So this is the first view of the software. After that, if you click the new schematic, it seems like this. So you can use this toolbar. There is a toolbar. You can actually see that the first one is the new schematic, then open, save, and then this is for the simulation. I will talk it about later. And then these are the zoom in, zoom out, and then this is for the delete this icon, and then this is for the duplicate if you want to paste more resistor rather than doing it from the library. Just you can duplicate it by clicking on this icon. So, and then this is the for the wire. We will do it in a while. And this is for the ground placement. Ground, you have to put the ground in every circuit, at least one ground. So this is the symbol you can take directly ground, and then this is for the labeling, and then this is the resistor, and then capacitor, inductor, diode, and this is for lot of elements you can find here. This is a whole library. The sources are also there, the voltage source, the current source, and different sources we will see in a while. And then this is the move and drag button, do, undo. These are the normal things. So this is the brief introduction of the toolbar. You have you can access directly different elements from the toolbar. So if you click on this device, this will appear. These are the resistor, capacitor, inductor, and this is for the whole library. So there are different elements here. You can see ADC, DAC, filters, and there are different ICs for the, maybe there are also converters and LEDs, and this is load, and these are transistors. You can select from there. Just click on this AND gate. This will appear. I will show you later. And then this is the circuit I made. This is the high pass filter. Now I will move to the software so that I can show you the actual simulations and circuits. Okay. So if you click new, this is the new. So then you click this resistor, place here, and then capacitor, place here, and what else we need? Source. So you will click on this diode button, AND gate button, and then here you get different sources, resistors. This is the load, LEDs, and these are the libraries. You can find, if you double click on that, you can find the different ICs here. So you can have the IC, and there is also a test fixture, that is test circuit for this IC. For example, if you click a test circuit of this IC, it will open a sample circuit for that. You can simulate and play with that. Okay, let's go back. So if you go back, this is the voltage source you need. Just place here, and then okay. Okay, there are, you can, this way you can place different components in the schematic area. So let me, yeah. Control R is for the rotation. So you can select this wire here, and then left click on the terminal, and then draw the wire. Just to for any second. That's it. Your circuit is complete. Now you can label it. There's different labels you can do without any port and with port. If you want a port, you can write it like this, and then, but I do not need this, so I just use the label only without any port, none select, and then just write V in and click on this, and then again label V out. So this, so V in, V out, and this. And for the each circuit element, you can right click on the circuit element, then its parameter. Yes, you can write here whatever resistance you want, whatever tolerance you want, and this is the capacitor parameters. You can write how much capacitor you want, and for the source you can actually, okay, for the source it's it says DC and resistance. By default it is on this, but if you want different sources, go to the advanced, and then you have there you have different sources: pulse, sine, exponential, and then PWL, whatever you like. Just sine, if you select sine, 1 volt, frequency 1 kilohertz, maybe. Okay, that's it. So your circuit is complete with parameters. This is low pass filter, but I want to show you the high pass one. This is my filter already. already designed. There's another thing, you have to save it. Maybe because by default it gives a draft 1, 2, 3, 4, 5. So it's better to use some reasonable uh, naming so that you can recall it after many days. So just write it some reasonable name RC LP filter. So okay, and this is the way you can actually build different circuit in this schematic. And then again I go to the slides. It's, yeah. Now we design the circuit in the simulator. So there is a man running. This means that this is the simulation run. This is run. You can run the simulation by clicking on that button, but before that you have to configure the simulation. How much time you need for the simulation and how much step you will do configure for the simulation, the step size of the simulation. So okay. This is, I will go again to the software. Okay, here is the man running. You can click on it. Run everything. So default this. False. Okay. What's this? Okay, before running the simulation, you have to set different parameter for the simulation because it's 1 kilohertz signal, so you need at least 1 millisecond to track one cycle. So I put it 5 millisecond, 5 cycle will be shown in the simulation. Start time is from the 0. You can skip start time if you have instability at the starting point, but normally it is from the 0 so that you can see how the circuit progress from the transient state to steady state. So for you it is normal to say. Maximum time step, it tells that there is time 0 to 5 millisecond, and then how small should be the size of the simulation set. So simulator do 0 to 100 nanosecond, and then 200 nanosecond, and then 300 nanosecond, so on up to 5 millisecond. So this is the step size. Smallest step the simulator will take, and the startup condition you can select. Okay, when you click OK, then this will appear in your schematic. Transient simulation 0 to 5 millisecond and 0 to 100 nanosecond is the largest time, and with the startup conditions. So when you did the simulations settings, then you can run the simulation. So before I run the simulation, I would like to go to the chat box. If you have any questions up until now, you can speak up or you can actually write chat. Any questions from the placement of the components and on the setting of the component parameters and then the simulation settings? No, no questions. Okay, then I will run the simulation now. Okay, when I run the simulation, there is a graph appears. So if you want to see different voltage, just scroll your mouse there, and then you can see different voltages wherever you like. Just click left click on the any wire, any node or pin, you will see the voltage waveform. So it is V out because it is labeled. So voltage waveform, and this is the waveform at the output. So if you want to measure the current flowing from the resistor, then you have to click on the resistor. If you move your cursor on the component, then it will give you the value of the current. So just move your cursor on the component and then click left. So this is the IR. This is IR and this is V out. Okay. And then just okay. V out, you can click on the V out and you can these cursor will appear. On this cursor you can move the cursor up and down and see the horizontal and vertical values. You can see, okay, this is the peak value is about 1 volt, and then here it is minus 66 volts at 2.4 milliseconds. So you can measure voltage value at different by clicking on this label. And if you hold control and then click on the label, it will give you average value, RMS value of the waveform. If it is current, it will give the current average and RMS value. If it is voltage, it will give average and RMS value of the voltage. If it is power, then it will give the average and RMS value of the power. So for the there is another thing. You can also measure the potential difference. Okay, for the potential difference, you just need to click on one wire and keep pressing the left button, left mouse button, press on the other side of the component. It will give the potential difference. So it will give the difference between V out and V in. Okay. So you can measure current, you can measure the voltage at some point, and you can measure the voltage potential difference at the component. So there is another measurement of power as well. For power measurement, you can actually click on the press the Alt and go to the component. It will show you some temperatures symbol on the component. Here, if you click on that, just left click, go to the component, press Alt and click left of the mouse. It will give you the voltage, the power. So the power. Let me show you on the power. Okay, this is the power. So you can see by this cursor the power value at different time scale, and also you can, if you press the control button and then press on the label, you can see the average power and integral of the power waveform. So this is the way you can actually see the voltage, current, and then press R power. There are you can click on any component and you can see the cursor. You can press this, and the cursor go to the voltage waveform. You can press this, cursor go to the power waveform. If you press Alt, control, it will bring the voltage, average values, and it will give you power average value. And if you click on by pressing control and then click on the left mouse button, it will give you the average and RMS value of the current. So you can measure, you can simulate and then measure voltage, current, power, and their average and RMS values as well. Peak to peak, any instant value by the cursor, and the average and RMS values. So I will go again to the slide. If we have everything, yeah. So you can observe different values. So this is what I already talked about. You can probe different circuit points. Just left click on the wire, it will give you the voltage of that wire. And if you want current, you can go to the body of the component and then just click left, it will give you the current waveform. And if you want the voltage difference, left click and hold on the node, go to the next node, drag the mouse, don't release the button, the left click, drag it to the other node and then release it. It will give you the potential difference, the voltage difference between both the points. So we already did it. And then this one left, okay. You can actually drag the box and you can see the values at the bottom, the differential values, the dx and dy. You can also do that. Let me go to the software again. We can see this. Okay, yeah. Just delete. Okay. Now click left and then just drag. So if you see on the most left corner, there is dx and dy values. This is the differential dx, and then this is 1.7 kilohertz. If you see, there is around 1 kilohertz, and then peak to peak voltage is 2 volts. This way you can measure the differential wave shape differential voltage or currents or power. You can zoom. Zoom is also the same way. So there is also zoom, and then this one for the default. You can zoom out, and this is zoom in. You have to drag it. So okay, then again to the slides. Yeah. So you can measure peak to peak over a period. Yes, we already see this. Okay, here. We also did this, the average and RMS current, voltage and power. You can just press control and then left mouse on the label of the wave shape. This pop-up will up, and then you can see the average and RMS values of the waveform, whatever it is, current, voltage or power. So instantaneous and average power dissipation. This is also, we have seen that if you can hold the control alt key and then left on the body of the device, it will give you the power wave shape. And if you click on the wave label by pressing the control, you can see the average and average power of the circuit. Okay, this is all for today's session. So you can measure the voltage, current, and first of all, you can design the different circuit on this simulator, and then you can simulate different circuit. And in this simulation, you can do the voltage waveform. You can see the voltage waveform, current waveform, power waveform, and the average and RMS value, or instantaneous and average value. So, and also you can measure the voltage across resistors, current flowing in the load, uh, current flowing in any component. So I would like you to practice it at your system if you already installed it. And I am here to help you out if you got any problem. I will open the chat box. Let's check it. Okay, any questions from this simulations and the measurement part? No question. Then please make a circuit, high pass, low pass filter, or high pass filter, any filter. Oh, rotate is I think alt and, let me see, alt and R, alt R. This. Okay. 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 Please some component here and then click on it. First of all, let me select it, and then yeah, you have to select it, and then you can press Control R, not Alt and R. Sorry, it's Control R. So first of all, you have to select this component, whichever you like to rotate, and then Control R. Okay. Where is chat? So, okay. Any other question? Move it also from this hand. You can, if you want to move, you have to click on this hand button and then select the component. I could not understand the question. Reduction between 2 points. The potential difference, you mean? Okay. Okay, yes, no problem. If you want to put the chat the site. Okay. For the potential difference, you have to just click on the wire, left button, and then just press the left button, drag it to the next side of the component, and release the left button. It will give you the potential difference. click and then keep click, put drag it to the other part of the component and then release it. So you have to put on the wire one side and then other side on the wire. Okay. Okay. For the frequency session, I didn't try it yet. Let's see if we can do. I don't know. I think normally software allows it to put different variables here. I'm not sure about this. Or maybe because it's, I think, okay, VF. But the problem is that there is nothing where you can change the variable after that. So it will not allow you to put any variable here, maybe more than pi. Maybe expression, we can try that. No, it will not allow. So I don't think so. Because there is no where you can put the definition of pi. So you have to put the values here. But you can use K, mega, and the units here. You can do that, but not the variable. Because normally software will give another simulator where you can put the definition of the variable. But here there is nothing you can. It's just Spice. Actually, Spice is very not very user friendly software. It's more uh, programmable software. You can program, you can write programming as Spice. But this version by Analog Devices, it's quite good for the user interface. Normally, Spice is not that much good. You cannot put pi and different variables in these devices or in the components, because you have to give the definition. There is no place where you can put the definition. Okay, anything else? Please simulate maybe this circuit, same circuit, and practice the voltage, current, power, average value, RMS values. And I am here maybe 10 more minutes to see if there is any problem you got during the simulations. Everyone installed the software. You can press yes if you did already. How many people installed the software? Okay, good. Very easy. It's very easy because you are electrical engineer, so it's not a problem for you. It's very easy to install this software. Did anybody design the circuit in the simulator and simulated it? Nobody. You can write yes Simulated maybe. No, yes is already in the chat box. If you simulated the circuit, then just write simulated. And meanwhile, any other question about the simulations, any other problem, or you want to share any problem you faced and then you find the solution? Okay, nobody simulated it yet, so please simulate it. Okay, there is this A button in the toolbar beside ground. Okay, one thing I left to tell you that this is the ground you have to put in the circuit. Okay, without this, the simulator doesn't work. So there is this symbol net name. You can put the name whatever you like and then press OK and then click on the wire. You can place the label. So if you want a pin, you can select input pin, output pin, the output pin, the out. Here is the output pin. You can place this output pin. You can add labels or pin by click on this symbol. Port select none and then write V in and then just click on the wire. It will be label. Okay. And for the delete, you can take this scissor or you can press the delete button. It will automatically appear the scissor. You can delete any element, any waveform by pressing the delete button. The scissor will automatically appear. This is the short key of the cut. So there are other short keys as well, like R for the resistor, L for the inductor, C for the capacitor, D for the diode. Okay. Did you get that? How you can label the component, the wires? Okay, okay. Thank you. Any other problem? Any other thing you want to discuss? We have time. Please simulate it so that I can help you. The simulation if you get any problem. There is, I think. Okay, you can actually see the data sheet as well. Click on the component, right click on the component. You can open the test circuit or you can go to the website for the data sheet. So you can actually directly access the data sheet by clicking on the device. So this is a very nice feature of this software. Okay, and other thing, I think everything is covered. And if you need any help, you can contact me, email me, and then we can set a Zoom meeting to help you out. Okay, did anybody get the simulations? Okay, any other question? Any other problem? Is you can just click on this symbol and just left click on the schematic. It will be pasted. And if you want to copy paste, okay, let me. Okay, if you copy this, it will be pasted. Just press this copy button and then click on the device and then again click on the schematic. And maybe there is some problem. Get it? Okay, that's good. Good. Any other problem? Please feel free to ask if you have any problem. So nothing is small. You are new, so you can get problem. Just ask. It will save your time. Okay, any other thing? Oh yeah, there is another thing I want to tell you, that you can actually make a copy of your circuit from there. Go to the tool and then copy bitmap to clipboard. It will copy the circuit in the clipboard, then you can paste in the Word or Paint it or any other software. And it is also actually saved in this its library. So it will be appear in the bitmap will appear in the library where the all files are saved in the document. So if you this yeah, this is good idea to show you the place where everything is stored. If you go into your document, by default it is the path. If you go into your documents and then there is LTspice version, so there is different here. This is the bitmap for this problem. Maybe I have to open it in the no, it's not open. It needs another software. Look at this one. Really open it and paint it. No. Okay, you can copy in the clipboard and then you can paste it here like that. If you want a zoom in version, you can go to the tool and then copy bitmap to the clipboard, go to the paint it and then just paste it and save it wherever you like. Okay, you can get the schematic as well for your report. If you want to write the report, you can do that as well. So, okay. Okay, did anybody completed the simulation? Or stuck in a problem? Just ask. Okay, you got nothing, any problem? No problem. Good. That's good. It's not that much difficult. Okay, did anybody did the simulation? Completed simulation? Or stuck in the problem? Then ask. Okay, good. Good one. Good, good, good. Any problem? Any problem? Okay, that's good. Two people completed the simulation. Okay, any other person? Anyone got any problem? Okay, no problem. Okay, we have 7 more minutes, so we can wait. If anybody got any problem, we can. I can help. Hmm. To choose different types of diodes. Okay, you can actually any component for any component it's the same. You can click on it and then pick new diode. Every component had this uh, new or some, for example, first we see the diode. Okay, just click on the diode, uh, right click on the diode, pick new diode, this will appear, and here you can see different companies, different diodes, different specification. Mostly used specifications are already specified, but if you want to see, you can go to the model number and see the data sheet. You can see the data sheet of different diodes. So there is a list of diodes you can select. So same with the other components. It's if you see, if you select here, select capacitor. So there is select capacitor button. If you select it, so you can see there are different types of capacitors, different company capacitors, and there's some specifications as well. If you need more specification, you just write this part number and you can download the datasheet from the website. So any other thing? Yeah, that's very good question. I actually forgot about that. Uh, that's very important actually. Okay. Okay, any other question? Any problem? Okay, that's good. That's good. How many more finish simulation? Wong and Yun completed their simulation. Any other completed their simulations yet? Okay. Nobody completed it yet. Okay, yeah. If you completed the simulation, you can leave the Zoom meeting. I will stay 5 more minutes so that if anyone get any problem, I will be there. Okay, thank you. Okay, any other person got any question, any problem, you can ask anytime. Okay, how to set ratio of peak to peak. Uh, um, the voltage source, or you want to measure peak to peak? Voltage source. See, for different signal, There's time delay theta DC offset. It normally I think there is no option you can actually select non-symmetric sine wave. If you give 1 volt, it will automatically give 1 volt peak, and then peak to peak is 2 volts. So it's like that. If you want 1 volt, just press select 0.5, it will give you 1 volt peak to peak. So it's like that. The thing, if you want pulse, then you can select the voltage. This one, I think, yeah. There are different times, different values. You can select different values at different times. But in the sine wave, you can't select different or unsymmetric sine wave. So you have to choose only the peak. It will automatically generate the peak to peak voltage. And it's not the normal scenario in the source of the sine wave. Did I answer your question? No. Okay. Thanks. Okay, if anybody don't have any problem or any question, we can actually finish this meeting. Anybody have any question? Any problem? Okay, that's great. Okay, there is no problem, no problem. Okay, no problem, then we can actually complete this meeting, finish this meeting. Okay, thanks for everybody to come here and join this meeting. Hopefully you get the idea how to actually generate, design different circuit on the simulator and then simulate the circuit in this LTspice simulator. If you got any problem or any question, you can ask me by email. You can get the appointment by email. Just email me and then I will answer your questions. Okay, see you guys. Bye bye. Bye bye. Thank you. Thank you.